Okay, this is my first time doing something like this. I probably won't be live for very long, but just probably gonna read and try and figure some stuff out. That's gonna be the goal. Maybe play around with some of these default projects and stuff. I don't really know anything about this, so it's going to be completely new to me. So yeah, hopefully it's fun. Maybe not. Let me drop the link for this. There will be no actual deving today, because I finished the refactor, and that's that. But as far as, like, you know, changing some variables around and playing with it, there will definitely still be that, hopefully. I've got a lot of extra stuff open right now, so I don't know. Getting this set up was really, really difficult and painful, actually. We should open another terminal. This is in here. So I just want to make sure that we have the builds. So all of this is done with CMake, apparently. It's very, very complicated. It was very complicated to set up. Incredibly difficult, actually. What's the build command? I just did it. Yes. This. Okay. Hopefully this works. It says no work to do. Maybe it's because it doesn't detect a change. I don't know how it really works, but the idea for today is I'm just going to have multiple terminals open here and maybe go for some split screening with the documentation and stuff. Oh, this is the wrong folder. But yeah, I'm also going to be reading a bunch of assembly, so that's going to be fun. I don't really know assembly, so but hopefully it'll be a bit educational. I don't really know. So this is the documentation, and by documentation it's just pretty raw code. It's not very readable, but the guy who made it is a genius, so that's always good. I trust him. Yeah, getting the toolchain to work with GCC was very painful. I am kind of worried about this, though. Maybe we try, like, commenting something out and then seeing if it okay, perfect. Okay, so we're set up here, actually. So something interesting already with our setup here is that we can't actually use this at all. It's going to say invalid AST. And that's because the way that this is built is so kind of separate with the libraries and stuff. There was no way for me to actually parse the documentation, so that's where we left off. It's just we just have to go old school with it, which is quite painful. So I guess how we're gonna start. Oh yeah, I have to actually use that because yeah. Okay. Yeah, something interesting is that all of these sample projects avoid header files completely. So they have these inline forward declarations for all of the functions. Something that I noticed. I did take a look at this before. I did figure out something interesting here. We're going to be doing a lot of global searching, but I kind of want to find this file that is the... This is going to be really hard to find, but I believe it's here, yeah. So this is the implementation for all the vectors and matrices. And obviously this file is pretty important to us, so we're going to keep this open in a buffer. So I've kind of done some Googling about this ordering table thing. It's kind of hard to find a ton of information about it. I should actually have Firefox open because I will be Googling a lot of stuff today. No, this says where I live on it. That says where I live on it, Firefox. Why do you even have that information? Okay, I'm just making sure that we're not going to get doxed here by Firefox. Actually, I should be in incognito when I go live, but it's not like you're going to see anything bad here, but you shouldn't really see all my search history. What was I gonna look up? Oh yeah, I was gonna look up ordering tables. Because I did find, earlier I did have this. Did see this earlier. I've got too many tabs open in my other... Okay. I know that I can highlight a PDF, actually. Thanks for letting me know, though. Yeah, so this is a way to order because we don't have a Z buffer. That's how they did it on the ps1. It's actually interesting already that this says that this is small with 10 different levels, because as we know already from... Oh, actually, this is massive. Oh, interesting. In a different... yeah, in a different implementation, I saw that this was 16. So this is massive. And, hey, what's up, LinkedIn? How are you doing? I'm trying to do something. Do you maybe have any Linux security hardening hints you can share? As far as like making your Linux setup more secure? I have no clue, to be 100% honest with you. In terms of security, to be honest, I don't know. I'm pretty safe. Like, since I'm not on Arch and I don't use the Arch repository, that's kind of where most of the exploits are coming through nowadays. And since I'm not connected to that, I guess I really don't have to deal with it, to be honest. The Ubuntu repository is really, really safe. So, I typically don't, this is kind of all that I do, is kind of this like coding stuff. So, I'm sorry, I don't really have a lot of tips. I use UFW and VMs, but I'll attempt to... Yeah, I mean, if you're doing your first Linux installation, I think that Mint is a good starting place. Like, I don't know. I'm somebody who likes simplicity, so, you know. Hey Ansel, how are you doing? Yeah, I'm reading today. I know it's boring. It's not. I finished the refactor, fixed all the bugs, and now I can show you what it, if you want to see something cool. We can see what it looks like. Oh wait, I just opened the wrong one. I just opened the wrong file, so it's called 3. So as you can see, there was a lot of logging that went into it. I can't really open up the code right now, so the reason why is because we're in a different kind of development environment today, because I'm doing all this ps1 stuff. It requires a different, but as you can see, we're back to kind of normal with everything, and then it's back to working. So that's cool. But yeah, I'm taking a break from the engine right now because this last refactor was quite painful. It had me really scratching my head a bit. So at least for now, I'm gonna be doing reading. I've been putting in the work. Yeah, I guess so. I guess I don't really see this as work, but yeah, we're gonna keep this here in case we need to. But yeah, we're learning about PS1, actual PS1 hardware today, because I'm interested in it. I have the ps100bsdk documentation up here, which is an SDK made by a really, really talented developer, and we're trying to learn about it. It's very, very complicated. His documentation is alright, but most of this is written in pure assembly. So can't you really like Pop OS? Yeah, I haven't really tried other distributions. I might one day. I might one day. I don't know. I feel like most distributions are just kind of like a slate to build off of anyway. Since I use i3, I don't really play with any of the real tools. Hey, what's up, Aria? How are you doing? Yeah, so 10 is really... You're learning assembly? Oh, that's awesome. Yeah, I wish I learned assembly. We're going to be doing a lot of assembly Googling today. So... to figure out what's happening, because I don't really know assembly that much. Especially the assembly that he's doing. That is, for example, if I try to look up the documentation for... This should be in one of these, yeah, here. Oh, this actually isn't in assembly. Most of these are. This actually looks pretty normal. But yeah, a lot of the other stuff is in assembly that I was looking at earlier to try and understand what was actually going on here. But this is kind of the most advanced example, is an FPS camera. I can actually show off for the people that are joining the stream. Let's open up another terminal here, and this will be our... So this is it. I'm wondering which one it actually is. I think that they both exist. So this is what it is. And also with Q and E. So this is the example. It's got full movement. There are some funky things about it. Like, velocity doesn't really work. Of course, you have the typical ps1 like texture mapping issues when you get close to the ground. Aren't they about to drop support for duxation? Well, if they do, then I'll be screwed, because actually the only way to use ps100bsdk is with duxation. None of the binaries actually compile or can be used by Mendefin. So I should continue my research. Gotta clone my disk image as a USB burnable ISO after configuring some things. See you next time. Thanks for stopping by, Langtons. But yeah, so this is pretty... It isn't perfect. So these are strafing controls, but forward doesn't actually go forward. So but yeah, this is pretty cool. So this is like the most kind of advanced example that there is. And that's what I was looking at. Anyway, ordering tables. So this is how depth sorting was done in the old days, since you didn't have a Z buffer, you know. And the ordering table here, as I showed off earlier, is 1024, a massive ordering table for a 3D scene. And so it's a lot of memory. I wonder how much unsigned long. So thinking in terms of memory, that's a lot. 1024 is a lot. An alternative to having a huge main array is to use multiple ordering tables. Thanks for stopping by, I appreciate that. Reading is fun. you definitely have to do reading with this. There's no, you know, there's no real way around it. Trust me. If there was, I wouldn't be performing 3D calculations at each primitive. Yeah, trust me. You ask like an LLM about this or search this stuff on YouTube, you're not gonna find anything. I'm sorry to break it to you, but that's just the way it is. Hey, anyone here know how I can learn C language? I need a good one, not just type syntax. Well, maybe I'm not the best example, but I learned C. I kind of taught myself. I think it's a wonderful language. There's a few great videos you can watch about it. They are pretty long, but what exactly do you need to learn in C? Is it memory management? Is it, you know, types? If you know all of your syntax, then I use for low level. Yeah, I mean, me too. There are some great shorter videos by that guy in YouTube, Low Level. I really like his videos. He's got a really great one on void pointers, and stuff like that. Definitely recommend some of those videos. Really good for understanding what pointers actually are, and that types attached to pointers are, at the end of the day, just a number of bytes to read that you're telling the compiler. He's got a great video on unions too, so highly recommend him. Hey Luca, I don't know if I've decided yet. It's pretty painful. I'm not gonna lie. There isn't really great documentation on the PS1. It is extremely low level. We're looking at the documentation here right now of an SDK just made by one guy. And, you know, he's a brilliant guy, but reading through this documentation is really hefty. It's very, very difficult to make out what's actually going on, so we're doing some reading. It's kind of no way around it. Yeah, I mean, he's brilliant, the SDK is brilliant, but there's a reason why there are no PS1 homebrew games that are being made nowadays, and it's because it's incredibly difficult. But I think it's still really interesting to learn about, even if I don't use the information. I think it's pretty interesting to learn about. But yeah, the PS1 is really limited, actually. It's kind of amazing now looking at the capabilities of the PS1 and thinking about like Silent Hill. Like, wow, like it's actually amazing what they got out of it, because yeah, this is absurdly difficult, you know. Basically all of the matrix transforms and stuff have to be done in assembly, and most of the documentation is in assembly. I know that a lot of this that we're looking through is in C right now, but if you go through here, a lot of it's in assembly actually. So I notice he has two of these here. Is a double buffer for even the ordering table. We got to the moon with half the power of a PS1. You can make a PS1 engine. I mean, I don't actually know if a PS1 engine is technically possible. Not at least in our kind of sense of an engine. Like, technically, I could make maybe like an FPS engine, but to make a general game engine for the PS1 would be really impossible. Be super impossible because it has to be low level. The way it's designed is kind of low level. Yeah, so this is unsigned long, just like what we're reading about. I don't know what this is, but I'm pretty sure that packet buffer is actually just like our draw buffer, our one draw buffer. And talk like I've been PR trained. Really? I mean, I think that that's a good thing. I think that you have to be PR trained to be a streamer. One draw buffer? Luca, you don't know. You don't understand. So there is no Z testing. So that's what this ordering table is for. This ordering table is what we're learning about here. This is how you sort by depth. And yes, I'm pretty sure you just have one draw buffer. Or it's those packets. This is our packet buffer. This is everything that we pass to the GPU in a frame. I'm pretty sure. That's what this is. This db active equals 0 is probably just a flag to index this. I don't know what this is. Yeah, looking at this code is pretty much just like, you know, kind of like reading a different language, especially these. These are all, if we do a search for some of these functions, like GTE AVS3, we'll find the implementation somewhere here. Yeah, so this is what I was talking about. These are all assembly. Yeah. He did all of his own kind of math implementations in just pure assembly, which makes it kind of unreadable. Like, I don't really understand what any of this does, but he does have some performs rotation, translation, perspective calculation of 3 vertices at once. The equation performed is the same as GTE RTPS, only repeated 3 times for each vertex. Yeah, it is pretty crazy. I agree. This is why nobody is making. If you look up PS1 homebrew games, that's why nobody makes it, because it's really, really, really complicated. These are all macros, though. Like, at the end of the day, it's just assembly macros, but now the PS1 was incredibly incredibly limited, and that's why it has all these assembly things, is because it's trying to get like the most out of it, you know, as possible. It all has to be extremely performant, especially to do anything in terms of like first person. So this is kind of relevant. Averages the values of GTE registers, multiplies it by this, divides the result by, before storing it to this, used to compute the ordering table depth level for a 3-vertex primitive. 3-vertex primitive. So 3-vertex primitive is just a triangle is what this is talking about. Elias Dollar. I don't know that name. I saw somebody on YouTube that was doing something with PSX, I think. I forgot the name of his channel. Oh, you're giving me a link to Twitter. I don't have a Twitter account. So... Oh. I might not even be able to view his thing. Making a brand new game for the PS1. Oh, this is sick. Oh, this is awesome. Wow, this is awesome. I kind of wish I knew kind of his, what he, you know, his kind of pipeline or whatever. Like, I don't know if he's using the same SDK. But obviously he's been working on this for a very long time. He has a kind of a big article I see on Vulkan. I mean, a year is pretty long to me, but yeah. Oh, I should totally watch this. Thanks for letting me know. I couldn't find anything about it. It's still probably really useful to watch some of his videos, even if I'm working in first person, so I'll save it. Thanks for letting me know about that. Hey, what's up, Lloyd? How are you doing? I'm pretty sure that it has these functions actually. Clear OTag R. Yeah, I saw these earlier. Clear both ordering tables to make sure they're clean at the start. And I want to look up the implementation of this, which is... Ooh, this is going to be difficult to find. Did I miss it? Oh, it's in this header file. PSX GPU. Yeah, it is really niche. I was really surprised that it is so niche, actually, because the PS1 aesthetic is so huge. You would think that there would be more interest in it. Oh gosh, this is so hard to find, apparently. I kind of need to find this file, though. Why can I not? Oh, did I put a 0? You'd think that there would be a better way of searching, but there actually really isn't. Here. See some PS1 style stuff, but nothing specifically. Yeah, exactly. Yeah, it's really impressive to do work on the PS1 hardware, which is why I'm kind of interested in it. But it's not easy for sure. Also, something that you may notice is that this doesn't even, talk about textures, by the way. Like, this isn't even textured. The example that we're in right now, it's all done just with math. So there's a reason for that also, is because, if you have FPS kind of style, texturing is really difficult on the PS1. I really do. I wonder what this is for. SDK validate args void. This is on every single function. Does this just is this basically like early return macro? That's what I would guess. Okay, yeah, it is a macro. Okay, it's basically just if we have a pointer and it's null or a bad pointer, then we discard an early return. That's all that is. One video on PS1 game engine, I don't know if it's useful. It's by bandwidth. Yeah, I saw it earlier. It's kind of, I don't really know if it's 100% if I would call it a real engine, but it does seem to know his stuff, though. Was a very cheeky video, though. I didn't really get much knowledge out of it. Another annoying thing is that I don't actually even have a PS1. I have my PS2, but I don't think my parents never got me a PS1, actually. Fun devlogger where half is, yeah, exactly. But I don't like to talk shit, especially for a guy who probably knows more than me about it. Yeah, like this, for example, when you look at why not make a PS2 game? I mean, Shadow of the Colossus looks great. I thought about making a PS2 game, but it's just kind of been done before. Like, PS2 homebrew is like a real thing, you know. And there's already a game engine for PS2, you know. So it's not really as exciting in terms of like uncharted territory. But yeah, I think it would be cool to make a PS2 game for sure, and it would be cool to be able to test on real hardware for sure. If I commit to this, then I'll probably buy a PS1, yeah, but yeah, so for example, this stuff, I mean, it multiplies this times 16 and then adds it to this. What is that? The IO base. Like, these macros are very, very confusing. Hardware registers definitions. Interesting. I definitely have to look up about the registers, but like, is address the like a byte offset basically of where in the register we're looking, is, you know. So like, what is, yeah, I might actually have to like open like Google to get like binary conversions going, because I don't really know what this is. So it says 3 registers. And it sets a pointer to the last value, the last member of the ordering table. Yeah, I'm really confused on what this while loop is really doing. Because it's not actually changing anything, right? Like, this is... Like, we're bit shifting this. Unless this macro is actually doing math. It's pretty funny, actually. Like, so much of this is like reading a different language, but you go to the look at implementation and it's exactly what I have in my engine. I'm like, oh, at least I have that one. At least I have that one. We can't even go to the init function, really. Drawing API. Okay, so this is actually kind of a nuclear style call here that sets up a quad. How it actually handles the drawing, since it obviously isn't using GL. Well, it's definitely a lot different than OpenGL, that's for sure. It's a lot different than OpenGL, that's for sure. As far as like how it does actual drawing, I'm not sure like 100%. Like, I've done some Googling about it, but you basically send it. It's all like people just say online, like, oh, you're just sending packets to the GPU or whatever, but I don't actually know what that means. But yeah, it's all done. There's no actual like depth sorting, so you have to do all the sorting yourself and then just draw in order, front to back or back to front. But I'm pretty sure it's just like, you know, regular. It's all triangles at the end of the day. What is TW? We have to go to... I mean, this is going to be impossible to find. Oh, actually, it's here. TW texture window. No clue what that means. The rest of this makes sense, like if we're applying dithering. I wonder what, yeah. I mean, simply ord to T page. Initial T page value. This is like a great comment here. I mean, the guy's a genius, but this comment, like what the hell is it? Yeah, it says T page. What is a T page though? I don't think I'm gonna find out in this file, that's for sure. So everything's double buffered, that's why it does it twice, which makes sense. This put draw environment is what swaps the buffers, I guess. I don't know if I still don't understand what this function actually does. We have this still. So I'm using either the... What is... Okay, so it's reversed. It's reversed. Okay, so this is the end of the linked list is at the 0 index. I don't really understand why you would want that. No, it's going in one direction. So this is the end, the logical end, right? And then this points to here all the way up. And then this is the terminator, which is our way of saying that this is the end. I guess it's more efficient than just having a separate count. So I guess that we have to get used to arrays having terminator values that are this. I don't really understand why this is faster than having a count, but because like in my mind, memory layout, maybe it's a memory thing, but it is kind of strange. Like, don't you have to check every time you iterate through the list if this is the terminator? Isn't that like wildly inefficient? Rather than just going to a certain value? I don't really understand it. The PlayStation libraries and hardware. This value is found in the lower 24 bits of the tag field. Yeah, I guess I don't really know. Not really. If you get to behind the head, it is automatically null if it's not circular, it's cyclical. I guess. It's just like, to me, it's like, isn't it just like, if we iterate if we have a separate value that's a count, right? Then we know how far the linked list goes automatically, and then we know where to stop, right? But if we have just one terminator, don't we have to check every single time that we enter a new value if this one's the terminator? You see what I mean? But maybe I don't really understand it. Going forwards, yes. Going backwards, no. Yeah, I guess going backwards, no, but you need to know the end, the size of it anyway, right? Yeah, we saw this function earlier. This function takes as arguments a pointer to ordering table array element and a pointer to a graphics primitive. Pretty sure the graphics primitive is just a polygon. The ordering table parameter can simply be an address of a pointer rather than an array. For 3D graphics or pseudo 3D, the parameter should be a pointer to the element of the ordering table array that represents the z depth of the primitive. For example, I see. To this polygon use okay. Okay, this makes sense to me. I really wonder how you calculate depth, though. I guess you make some sort of scale. We'll have to look at how he does it. Same primitive cannot be added to an ordering table more than once. Doing so will accidentally delete other primitives. Okay, so it depends on the structure of the list. If it's a doubly linked list, you don't need to check each node if the previous one is null or no, because you move it, the node already knows the previous is null. Assume that it's a doubly linked list, because usually you can iterate back on doubly. Okay. Isn't a doubly linked list, this is linked backwards as well? It's linked to both ways? At least from how I understand it, it's only pointing in one direction. To the previous and next node. Yeah, this only goes one way. 100%. But maybe I'm not understanding something about how the hardware works. Maybe it is just faster to compare the Terminator, I guess. I don't know. The other table? It's the same table, it's just this one goes backwards. And this doesn't link to this. It only goes that way. And this is just pointing to here, it's just the Terminator. Oh, I get it. I'm being stupid. I'm being really dumb. This is a pointer to the Terminator, not the Terminator itself. I'm just being really, really dumb. It just gets here and then it goes here. I thought that it was actually stored on the list. I'm guessing that the hardware knows once you point to a Terminator, or once you point to somewhere that's like really far away, I guess. It just knows. I mean, maybe I sound like an idiot right now, but... Adding a second primitive at the same depth as the previous one would result in this. 2 points to 1, 1 points to 5. Okay. Understood. Two at depth 7, 1 at depth 1. This is pretty funny. This is like this is like one of those mazes you get at like a children's restaurant. Not a children's restaurant, but on a children's menu at a restaurant. Okay, I mean this is I understand. This is how the PlayStation used the order table, so it just goes through. Yeah, I think that... Yeah, it isn't a null. So this is a pointer that goes to the tag, which is stored somewhere else. I find it interesting though that the Terminator tag isn't just null, or you know, it's some hardware thing probably that I don't understand. But I've gotta really, you know, just trust the documentation here. Yeah, I think it's a specific hardware thing where it compares against this in a very efficient way or something. So yeah, this is you asked how we draw on the PS1. This is how it does drawing. It just passes through the linked list and then draws every single triangle, and every triangle points to the next triangle. So otherwise, if that value didn't exist, it would just segfault. Yeah, it's stored. It's just a pointer to it. What does the draw triangle function look like? That's a good question. I don't think that we actually know, but we can actually. So draw O tag would be what it is, because that's the draw ordering table basically. So we can look for that right now. It's probably going to be hard to find since it's literally in every single. This drawing queue is some of the information on it. I was looking at that earlier. Let's try and find. So it's in PSX GPU. I think that we already had. Maybe it's in this file that we already have open here. Draw O tag. Return. In queue draw operation. That took us to a different header file. I don't even know what the name of this file is. Interesting. In queue draw operation. That would be what it is. Queue draw up. Let's see if we can find it. Here it is. Here is what the draw looks like. Let's look at an example here of what a draw call looks like. So we send. We're gonna have to look at what this function is, but we send a pointer to a function here called send linked list, and then this is something, and then this is OT. Interesting. I'm trying to figure out what the call is here. So this is just which buffer we're on, because it's double buffered, and then we take the ordering table of that buffer, and then we add it to, and then this is the Interesting. I don't really know how that works, because this is I would assume that this is a pointer. This is an ordering table, and then we add the OT len, which is definitely not a pointer. Strange. Okay, well, let's look at the actual draw function then. Well, I like C. I do like C. Thanks for noticing. This returns the length. I'm trying to figure out what all of this length is really talking about. It's obviously the length of the queue, but this is really interesting. I think that this is the key to really understanding. We pass a pointer to a function, which is send length list here. And then we pass all the arguments that we passed into here, into that function. So in this case, this is the operation type, the OT, which is the pointer, kind of starting a new programming project of build the game. And while I'm thinking about switching from C++20 to C99, feels way simpler to use it in some way that you understand. But then AI said, no, stay with C++20. Well, I would say stick with whatever you enjoy doing. If you like C, then do C. If you like C++, then do C++. I like C, personally. Well, Arya, you wanted to see what the draw function looks like. Now, what do you make of it? So, if not length, so if length is 0, then we set the queue length to 1. I like namespaces in C++20, but I use raw pointers mostly. But yeah, likely if you go with C, you have to write all your containers and things like that. Yeah, I mean, it's not really that big of a deal. I've implemented a vector many times. Not using inheritance for classes, mostly struct. Yeah, it's not a big deal. I think implementing your own vectors and understanding how memory works is one of the main best things about using C, because it forces you to learn it. So yeah, that's why I'd recommend C, because otherwise you just use the abstractions and you don't actually really understand things. But is this in this file? Yeah, these are static. I plan to use a lot of procedurally runtime generation. Maybe knowing these things would be great. Yeah, definitely. But I mean, I'm not going to tell you what programming language you should use. It's up to you and whatever you like to do. I'm trying to figure out where it changes the queue length, though. Like, as far as I understand, none of this changes the length. Oh, never mind. It changes it here. I'm blind. It just adds 1 to the length. So only when it starts a new queue. Does it execute that callback function otherwise. Are you using macros a lot in your code base? Sometimes. This isn't really my code base. This is someone else's code base that I'm reading through. But I got plenty of videos and VODs of me working on my code base. I don't use macros a ton, no. Int tail is the Q tail, and then the Q tail is the tail plus 1 modulus the length, right? Thanks, I appreciate that. I really appreciate that. Tail plus 1. So let's say we are at the maximum Q length, or the Q length minus 1, thinking in arrays, right? Let's say that the Q length max is 16, which it is, right? You get the tail, then you add 1, modulus 16, that puts you at 0. The Q tail becomes 0. And then length plus 1. And then, but then, so this is very strange that you're adding 1 before or after you check the Q length. So this means that if you hit 16 here, then only when we add to the 17 element do we actually drop the commands, which is pretty interesting. Usually it would be the other way around. See, it's just the correct answer to every question. The modern coding industry is not ready for that talk. Yeah. I don't really understand why you would use a different language than C. I feel like the only reason people use other languages than C is because they're forced to, because every library is now not made in C. It's made in Python and whatever. That's an 800 number, I'm not picking it up. Okay, so I get what the function is doing now. I do. So, if our length is 0, we set the Q length to 1, and then we execute the draw function. If our length is greater than the Q length, then we throw an error. Our tail wraps around, which is weird. Our tail is always trying to get the next. It's just weird because you would be getting the 0 entry here if you're at 15. At 15 plus 1, you wrap around and you get the 0. This is the first entry in the queue. And then you're filling the first entry of the queue. Oh, actually, that makes sense. So if you wrap around the table, then you're just, or if you wrap around the queue, then you're going to write into the first member. But what's strange is that I don't see a way that you decrease the queue length. It's always length plus 1. I guess that the function might decrease the length. So I guess it's time to look at that function. Send linked list. Now where we're going to actually find that function, I have no clue. Yeah, it's not in this. Oh, it is. See, this is the same line that we saw earlier that I don't really understand what this is doing. It's doing something with a register. It's saying assembly don't execute any code and just while loop until something. I don't really understand what this is. Yeah, it's quite confusing, right? Because we're casting pointers to ints. So we're casting the pointer into this register. I think we keep reading here. Yeah, so this is what we saw. We have a reversed ordering table, so we pass the pointer to the end of our ordering table in here, in display. This is what this is. It's just a strange pointer arithmetic, though, because dot ordering table, I wish that we had LSP set up, but we don't. Is this really allowed for us to do this? You might know this, but like, is this the same thing as us doing? No, right? This is not the same thing. Makes a pointer from integer without cast. Aren't we supposed to be? Draw OTag takes a pointer. Oh, I was being dumb. Hold on. I mean, I can literally test this out. I've got to make this faster rescan and then just go into here. This is the same thing, or else we wouldn't be drawing anything. Okay. interesting, I guess. Maybe I'm just dumb. I don't know. I wish that there was a way for us to print. But I don't think that we can. Which sucks. Yeah, I guess these are the same thing. I don't really understand pointer arithmetic, evidently, but whatever. I don't... Oh, we do have draw sync. We do have draw sync. I wonder what the argument is. Otherwise, an interrupt handler can be installed using drawSync callback function. The callback routine will be executed once the drawing operation is completed. I kind of want to do some... I want to do a test here then. I want to do a test here. Just to test out if is this even a thing in this SDK? This is an obviously drawSync callback. It is, yeah. Then let's try that. How do we do this? Let's just make a void callback with everything in it. And now let me try this out just to test this here. No, this doesn't work. Okay. Interesting. I guess I misunderstood something. The callback routine will be executed once the drawing operation is completed. Oh. Wait, what? What I assumed was that this draw sync callback would just execute this function when it finishes drawing, which I thought was what it this might actually be in this file. No, it isn't. Interesting. Sorry, it's a mosquito. Bold. I have insect repellent on today. That's bold of him. Yeah, I mean, this is just telling me a draw sync can be called to wait for the queue to become empty or get its current length, while draw sync callback may be used to register a callback that will be invoked once the GPU is idled. Maybe. Unlike the official SDK, custom drops. Custom drops can be pushed into the queue by calling in queueDrawOp and passing a pointer to the callback function in charge of issuing the drops command to the GPU, as well as up to 3 arguments. Yeah, that's what we were looking at before. Call setDrawOp type to let the library know. Yeah, this is kind of going over my head, to be honest. Some of this. I kind of understand what we're talking about here, but it is quite interesting that what's interesting to me is that draw otag calls enqueue draw op, right? So everything is just a wrapper over enqueue draw op, right? I almost wonder if we could iterate the ordering table like if I just did this, for example. Well, now this is kind of pointless now that we realize that this isn't even a thing. I'm kind of interested in, because it's a different instance, I have to do this. I'm kind of interested in, I have to do this. Kind of interested in if we can just do this. Dude, I think this mosquito just bit me on my hand. What a jerk, dude. What a jerk. Okay, never mind. We can't just do that because this is alright, peace out, Luca. Enjoy your CJing. I just don't understand how it iterates through the linked list. To be 100% honest with you. Like, how does it iterate through the linked list? It obviously sends this callback function, but maybe this is just it. Maybe this is just it. Alright, peace out, Aria. Have a good night. This will give us enough resolution in the area where most of our objects are located. Well, this just got really complicated, actually. Yeah, I don't really understand this. The end of your main table. Why would you do this? Doesn't this defeat the... Okay. Understood. I have to look for an implementation of this. This is interesting. I also find it funny that it's marge instead of merge. I don't really... Maybe that's a typo, I don't know. It's interesting that we didn't see any of this when we were looking through. Like, you would think that draw O tag calls next prim. Link field of the primitive p1 to a point at a primitive list terminator value. Understood. Okay. Got it. Okay, that makes sense. I feel like I kind of understand the whole ordering table thing now. I don't understand the actual implementation here, but I understand how to use it though. I want to see. Okay, so add prim. Trying to figure out this pointer arithmetic here. It's pretty... What is P? What is P? Let's not look at the cube. Let's look at the ground is kind of what I'm interested in first. So the ground should be... Let me find where poly F4 is. I'm pretty sure that this is just a polygon with 4 faces. Flat shaded quad. Primitive pointer. Define primitive. These macros are used to define 2 variants of each primitive, a regular one and a tagless one, without the OT header. Oh yeah, that makes sense. So this is a quad. I guess that the other ones are somewhere else in here. Oh, I see. It's just abstracted away in a macro. I'm very interested in what these are. These have UVs packed into them. And the aforementioned T page, which we still don't really understand what that is. Yeah, I wish I knew what the T page stuff is. I might have to do a Google for it, to be honest. What CLUT T page and pad 2 are. I guess FT is probably texture. Don't know what the F stands for though. F versus G. Where does verts come from? S vector, if I remember correctly, is the... I kind of wish we just used vec3, vec4 would be a lot easier to remember. But yeah, S vector is 4. Oh, I see. This is in 16. I did not realize that vec3s are in 32-bit. Understood. So that makes sense then. I don't really I'm never gonna figure out what these are actually doing until I give it a try myself. Average screen C result. Averages the values of the GTE registers, multiplies it by that, and divides the result. I kind of understand it, but why? How are we not passing our max ordering table depth? Why is it dividing by this and not our ordering table depth? That's my question. Maybe we don't actually... Oh, you know what? We probably don't scale it yet. That's probably why. And then this is sets a 3x3 color matrix. Matrix to the GTE. Matrix struct GTE control registers. Wait, yeah, I was looking at the wrong thing here. Sets the translation portion of a matrix to the GCE. S-tots. Takes an address to the int p though. Unless we initialize this to something somewhere. This is just the input loop. Yeah, I might have to do just some like random testing with what this does. Because I don't really get it. Okay. Okay, got it. Got it. Yeah, so I kind of get what this is doing. So we're setting the 4 quad vertices here. What I don't see... I guess that we send the address to the X and it does the X of the Y at once, is what this is doing. So we set 2 variables in one, essentially. Cicadas vector to GT vector register face. Okay. And then we do RTPS again. Now this is rotate point, and this is single vertex. I see. So this isn't actually Z up. Interesting. Okay, so this isn't Z up. That's what I was trying to figure out for a while here. This isn't Z up. I'm used to Z up. So this is basically XY in our typical type of graphics thinking, or at least my game engine runs Z up. The Z axis is up, but here Y is up, obviously, because this is the floor. PSN for real. Yeah, PSN for real. So we could do some interesting things here with the floor. So let's... $100 times half of the amount minus 50. This can be negative. Make the floor wobble. I'm trying to. I kind of want to make it have a y-axis and try something like that. I want to figure out how I would do that though. Sign of time. How do I even get time here though? That's a good question, right? How do you even get time? I mean, we can probably look up time. Oh, yeah, well, we're not going to find anything here. I wonder if there's any way that we can get time. Honestly, we could do something really, really funny here. Oh no. Does it mean to rotate a vertex? Yeah, that's a good question. I don't really understand it either. But I do know that every time he loads vertices in, he rotates them. So this loads in 3 vertices, this rotates 3 vertices. This loads 1, and then this rotates it. So this is the 3 first ones, and then this one is the 4th one that makes up a quad. Man, don't tell me you don't have a variable that counts how many frames have passed from the start. This isn't my code. But we can try it. Let's implement it. Let's call this can I do... Let's do this. Let's make it a global. Okay. We would... How do I set... Vertex is a single point, right? Yeah. Well, for this, it's a vector of 3 vertices. Or wait, no, this is 1 vertice. This is 1 So how would I set... I know we actually have this, right? So this is I sine of time, right? We can do this, right? This we know how to do. What I'm trying to figure out is how do we set the y? Like, obviously, set vector, we have to specify what it is. How do I just set the y of it? Good question, mister. Good question. Can I just do verts? We would have to do this. Oh gosh, I yanked it to the wrong register. It's so over. Okay. So this is going to be verts py px. So this is this as 3 times I plus 1 for the y. This, yeah, I know it's the second argument, but oh, actually, you know what we can do is go to s vector. Where is this implementation? We have to find the implementation for it for me to actually, I think it's in this file, s vector. It's in one of these buffers that we have open. S vector. Yes. S vector would be Vy. It would be Vy. Alright, I mean, let's go and see what it is. Okay, the ground is moving away from us. The ground has moved away from us. We're chasing after it. We're catching up to it. We're catching up to it. Oh, it's coming back because it's a sine wave. There we go. I mean, the whole thing is moving at the same. There you go. It's a sine wave, so it's going to keep on going up and down. I think it's at the halfway mark now. Do we have, can we speed this up? Can we speed this up? Do we have how do we speed up emulation emulation speed fast? There we go. There we go. Now it's bouncing. Giant chessboard. There we go. Yeah, that's a pretty massive sine wave. So that's pretty fun. That was pretty fun. We can definitely, we just like multiply this times 0.005 or something. Is this my own code in a ps1 emulator? Yeah, so this is not my code. This is, we are studying the ps1 SDK that this guy made, just to, because I'm interested in it. I mean, to be honest, ps1 homebrew is very, very complicated, very low level, a lot of assembly. Let's see Adam's formula here. Maybe we can do something fun with it. what is height in this case? Sine of time times speed plus vert.vx. Okay, let's implement it. Why not? We'll set speed to 5.0 f. We will set plus verts. That's a very big value. I don't think that we're allowed. I mean, we might be overflowing there. Max Y displacement is height. Okay, understood. Oh. I mean, we may overflow here. Max Y displacement. I don't really know what our values are like. I think that we're fine to just go 5 here. Let's try it with 5. Ooh. Oh, I misspelled. That's why. Adam, I think that this is funny code. Let's try a you know, let's try more reasonable values here. Let's try this. Okay. There we go. Let me turn the speed down again. This is cool. The amplitude is pretty insane. But hey, this is like, I mean, this is pretty sick. Got my LSP working with C++ modules. It was a very dumb, simple mistake. As I used Mason, it was using its own built Clang and not my system, and then I forgot experimental module support. Well, at least you got it working. This is pretty neat, huh? It also has this kind of, it has like this kind of, whatchamacallit, an optical illusion. If you like look at the top of the wave, it looks like it's rotating because of the way we're interpolating the points. Yeah, this is pretty sick. Thanks for telling me to do that, Adam, or else I would have never done that. I think that that's pretty sick. So this is where we set the color of the floor, and then we add the primitive at the end. It's very interesting. I wouldn't even know where to start with drawing my own thing, though. Let's challenge ourselves, though. Let's challenge ourselves here. And let's try to make a wall. Let's try to think about how we would make a wall. Let's think through it and try and figure this out from scratch. Okay, so if we want to make a wall, obviously we're going to be doing this instead of this, which makes sense. Right. Does this library have primitives? Yeah, so these are all, so this is a polygon 4 with 4 sides. So this is a primitive square, right? And then we set up the 3 first vertices here. And then this one does the last one. I'm trying to figure this out still, to be honest. So this loads 3 vertices, and then this loads the last vertex for the quad. And then you rotate. There's this rotate here, and then there's this, and then there's this. And I don't understand what these do at all. Triangles. Yeah, so this is the triangle, and then this is the 4th point that makes the second triangle, right? But I don't really understand what these rotates do and what this does. It's all in assembly. So if anybody understands what this does, let me know. Like, performs rotation, translation, and perspective calculation of 3 vertices at once. Yeah, but it doesn't take any arguments or anything, so it's pretty I don't really understand it, but yeah. That's how we make the triangles that are colors. Basically normalization, maybe. Maybe. Yeah, I don't really understand what COP2 and these binary values are. It's confusing. But I'm going to try to make a wall and try and figure out that way what it's doing. So this is 100 times. This can be negative, by the way. This is, so at 0, this is negative 8. Negative 8 times 100 is negative 800 minus 50. Right? Yeah. And then the next one is negative 7 times 700 minus 50. So negative 750. Okay. Okay, so it's in 100 increments, right? Okay. So if I drop this to 50, then we can change the ratio here, which is what I kind of want to test out. So if this is 50, and this is at 0, 0 minus 8 times 50, minus 50, and then when this is at 8, 8 minus 8 times 50, minus 50, 1, 1 minus 8, wait, 9, 9 minus 8, 1, 50 minus 50, 0. Okay. Well, it depends on how it is interacting with the graphics API. It can be that or some kind of global transform. Yeah, so, I mean, so this is what it is. It's loading 3 vertices into the register, and then it uses that register to perform the calculations. But yeah, so let's try and see what this would be like if we were to try and draw a wall. So we would have to make a polygon here. Set rotation and translation matrices. Let's actually see what this is. GTE set rotation matrix. GTE set. Sets a 3x3 rotation matrix coordinates from our matrix struct to GTE control registers. And the MTX is our view matrix? Is that? So that would make sense. Where's the MTX? Rotation matrices for geometry and lighting. Set rotation to the matrix. Apply rotation of matrix to transformation value to achieve a first-person perspective. Set translation matrix. What does set a matrix mean? Though it's very. Is that in relation to the camera or what? I don't really know. By the way, who writes code like this? It is so intimidating. I don't know. The guy's like kind of a genius, right? He wrote this entire. This is just one of his examples, right? But he wrote this entire SDK for making games on the ps1 from scratch. So it is quite intimidating, though. It is quite intimidating. Let me see. Is this being no? Yeah. So this db next primitive. Next primitive update. Very important. Why? Where do we define poly for? Alright, it's not going to tell us. I'm just trying to figure out flat shaded quad primitive pointer. Okay. So Oli just tagged back in, so the SDK is all wrappers for raw assembly. Yeah, pretty much. Pretty much. It's not all assembly, but a lot of the stuff in this file, which does all the matrix transformations, is raw assembly. It is kind of hard to understand what's going on, but that's what we've been trying to do during the course of the stream. We've been reading documentation about ordering tables and stuff like that. Some I use assemblies for programming a pick one did blanket LED. Oh yeah, I had an engineering class where we did a bit of that. We did like a clock, you know, like one of those clock things, whatever. On what do they call them? The boards with all the pins in them. What do they call it? A board, a something board. I remember that. That was a cool class. DB next prim. Okay, so listen, we'll just copy exactly what's happening here. Actually, no. We don't have to. Char pointer pol4. Pol4 equals db next prim. And we are going to cast that to poly f4 breadboard. Yeah, exactly. That was like really fun learning about resistors, capacitors, all that stuff. I think I would have enjoyed like doing proper engineer stuff, but kind of dropped out after that. I also wonder why this is looping to 16 and not a book called Hacking the Art of Exploitation, which has some in-depth assembly, but I've never actually made it through the whole book. Yeah, I definitely want to learn more assembly, but some of this stuff isn't even like... This is like advanced assembly, you know? This is like... I've never seen assembly written like this. I also want to, since this is, our vertices here are starting from here, we want an offset. So what's the max offset of this floor? The max offset would be, I'm guessing 0 minus 8, so 800 minus 50. So 850, negative 850. So we want this starting at negative 850, right? Like, is it just... Is it just that? I know that the original roller coaster tycoon was made by a single person in 86 assembly. Yeah, that's insane. That's insane. Assembly is pretty awesome, though. Negative 850 puts us there, and then that second negative 850 puts us... Yeah. That's gotta be it, right? Hold on, if we're at 16 minus 8... Yeah, that's just the other side. Okay. Wait, but this is the Y value. Wait, yeah, you want this to be negative 850. And this, you don't want that. I wonder if we can just draw that to the screen instead of making all of these, instead of doing all this math, but maybe we do have to do all this math. Every time I remember that, my stomach hurts. So someone made a whole RTS game using assembly. Well, I think that it's something that you just have to kind of get used to if you're doing like this actual like low-level programming on old consoles type of thing. I think that it all has to be assembly. Oh, we have to remember to update this every time we make a new primitive, I'm pretty sure. Yeah, so I'm not really... I don't even know what any of this does. I just kind of want to, like, try this. Just to see if this is just the way to do it. Set vector undeclared. Macro set vector requires 4 arguments. Did I miss an argument? That, right? Yeah. Yeah, I've tried plenty of Zachtronic games actually. This needs this. Conversion to non-skeleton. Oh, is that a pointer? That's a pointer. It's supposed to be a pointer. Yeah, I really enjoyed Zachtronic games. I never finished them, but I really enjoyed the one where you build the circuits. We appear to have crashed. I don't see anything. Oh wow, I'm 24 as well. Oh man. What did we do? What did we do here? Wait, what? Yeah, we crash. Oh wow. Just a bunch of 24-year-olds having a chat. No way. Okay, now, if I just comment all of this out, do we not crash anymore? Or does that crash have nothing to do with this code specifically? Okay, so we aren't crashing, but there's no floor anymore. Interesting. We didn't really touch. Let's run this back then. Oh, I used the wrong variable name. That would be why. Now are we back to floor? Okay, we're back to floor. God, seeing this makes me realize how good we've got it with modern game dev. I mean, yeah, so there was SDK. There was an SDK on top of it. But it was mainly assembly, yeah. You definitely had to code your own matrix transforms and stuff like that. It's honestly the reason why there weren't many first-person games on the PS1. Probably had something to do with it. Okay, now if we actually properly change the name of these variables, let's see. Let me see this. Ooh. Okay. Well, before we crashed, we did see the wall. So, my math was right on the wall. But we did crash, in fact. We did crash. Let's see, if we comment out the floor, are we allowed to trade the floor for the wall? That's going to be my next question. A wall was there, yeah. I did make a wall. Let the record show. Okay, we made a wall. For some reason we can't have a floor and a wall though. It's pretty funny because you can now it's just floor again. Okay, So that's pretty fun. That is pretty fun. Okay, so, I mean, how do we do this then? So there's something you're updating with the floor that you should update with the wall. It's the same exact code, though. I would agree with you, but it is the exact same code, though. And the wall is the exact same code, doesn't crash. I'm wondering if it's... I think it's next prim. It's something with this add prim, then this gets incremented. But this is a pointer, by the way. This is a pointer that's getting incremented. And then we set a char pointer, db next prim, right? And then I just grabbed the pointer for the next prim, right? Which should just be... We should just be allowed to do that. There would be something that says, okay, here, this... Yeah, so that's what this add prim is doing. That's what this add prim does. Is it, the OT plus P bit shift by 2 adds the primitive. Yeah, I don't really understand what this is. So this is pointer arithmetic here. The OT, by the way, is the ordering table. So this is a uint 8t pointer that we're adding this P. And this P is something that I don't understand. So this P we put in here. This P we're doing all this stuff with this P, but by the way, the only other place that this P is it's just an integer that's here. So we don't really know what the value of that P is, but we get it from this function, which GTE as tots is here. If anybody can read assembly and tell me what this means, that would be great. But all it says as for the actual documentation for all of these is GTE store macros. Hey, what's up, Luca? Any progress? Well, we have a wall. We made a wall. But if we draw the wall and the floor at the same time, then we crash. And we're trying to figure out why. Right, we get the next prim. Let's try. Okay, let me try something. Let's make another thing here. Let's call this what's your favorite letter? It's going to be K. So let's copy it with a new value. So every time there's a P here, let's just use a different value. H, too late. So let's try this. Ooh, we're not gonna make it. Okay, that's enough. Sorry for anyone who is epileptic. You think you get it? Really? See, we're fine until we start looking over there. Jesus, flashback. Yeah, we're fine until we start looking over there. Then we just start dropping frames like crazy. Oh, we're fine. We're not crashing now. We are not working, not really at a great frame rate. But ooh. Yeah, it's rough though. It's really rough though. It is rough. Maybe that's just the limitations. Like, we're already hitting the limitations of the system. Earlier I got my ears blown out by clicking a random Twitch clip about someone vibe coding a game in Godot, and the AI DB boosted their SFX like at 30. Vibe coders be like. Okay. Well, vibe coding in Godot. Yeah, how much more degenerate can you be? Yeah, there we crash. There we crash. Yeah, I saw this stream of this guy vibe coding. It came up in my recommended, and I saw him. I just like went to like a random point in his stream, and he was just typing into ChatGPT. He typed in, "I'm tired. Nothing works. Please help me." And I just thought that that was like the funniest shit I've ever seen in my entire life. Maybe we just need to make less polygons. I don't know what to say other than that. Test if quad is off screen. Tends to happen on texture polys. Interesting. Might be the same guy because there's a popular streamer who never does that who never normally does coding. Vibe coding GD script. That is crazy. That is crazy. It's crazy. Yeah, I feel like we should play around with this a bit. I also found it very weird that we had a different ratio here. Also, this was interesting. So let's do, this is going to be 425, I'm pretty sure. That's 425. I had a different ratio here, but I didn't actually see. So let's try something. Let's try to make this less GPU intensive by doing 8 by 8. 8 by 8. I kind of want to implement some culling. Yeah, that's what I was about to say, Adam. Yeah, I kind of wanted to do culling, but I don't know how to cull by distance. How would I do that here? I wonder if he has some documentation on this. Can I just like global search cull? Oh, actually, yeah. Polygon clipping. Polygon clip detection code. But this is only clipping. This is not actual culling. Yeah, the way I would do it would be to like just set a set of value, like based on our current values. I feel like that would be, let's do 500. Um, I don't know why I'm doing this. I don't know of VM software that supports GPU pass-through. I never use. Yeah, me either. I don't use it either. How do we distance test? Like you have to find the center, right? If a polygon have a vertex out of bounds, skip it. Yeah, but we have to find distance to the player. Okay, so let's find cam.pos. Cam.pos. So do we really want to test this is going to be actually pretty heavy what we're about to do, but can we do it while these are in the register? Yeah, that's what I'm about to do, Adam. I'm about to do it. Can I do this? I want to figure out how to do this in the register, how to multiply each times itself. I wouldn't even know where to begin with this though. Like, can I just look up multiplication? No, this can't be it. Averages the values of GT register. Maybe this is actually it. Maybe this is it. GTE. Maybe this. Wait, hold on. This. Where does it put the Z value though? AVSZ3. This gets the Z, which is the depth, right? Average screen Z result, right? So, where does it put it? It puts it in C2OTZ. I mean, OTZ. Oh, it's C2. C2OTZ. GTU register for? This is where all the math happens. I kind of wish that there was a way. Well, yeah, because the average value of these three vertices is in the register OTZ. And so, like, in my mind, I was like, oh, we can just use it. But I don't really know how to get to that register. Or how to... Yeah. Okay. Well, let's just do it the regular way. Let's just go wall py px. We're just gonna find disk squared, I guess. So let's just do this times this plus I wish I knew how to actually access the registers and do this on the register, because this is a truly painful calculation. So let's say we want this to be a UN32. I mean, this might be a really big number actually, but yeah. We need to get the... Wait. Am I being really dumb? We have to square root this and then... No, I'm being really dumb. We have to subtract first. What am I doing? So this is a vec3. We don't have vec3s here. We actually have an s vector. S vector dist. And we are going to set vector dist to... Wait, is the first argument here the dist? Let me see the other set vector. Yeah, it's the pointer to the vector. So this is going to be at this. We are going to set this to the wall py px dot vx minus the cam pos dot vx. I just invented the best way of culling. It's called vibe culling. That's good, man. That's good. That's good. Okay, isn't it just this? And then you just do it for the rest? I feel like this is... Oh. This is very... So this is now... We're gonna do dist. Right? And then you just take the square root and then you compare it to our constant. So this is how you do it. And then... Oh, please tell me he has this. Ooh, does he have this? Is this a real thing? What is this? I square root? Apparently this is a thing. I don't know if we're gonna find this. I square root. Ooh. Well, I global searched it and it's not coming up. Okay. The real part of the sum of the components of the first root of the is even draw if else don't. Yeah, that's what I'm doing. If the first vert of the polygon is even draw, part of the sum of the components of the first vert of the polygon. But I have to subtract it from the camera position. I guess if you want to fast route this, you could just do. We could just add linear. Like this isn't Euclidean anymore. It does vibe cooling. It has nothing to do with distance cooling. Oh, thanks. How do we find the square root though if we don't have a math thing to do it? Get square root fixed point. Yes! 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 Yes, dude. This is exactly what we needed. This is exactly what we needed. Yes, 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 yes. Okay, square root 12. I'm so hyped that we actually found that. Right? So this is going to return an int dist equals, and then if dist is greater than equal to max dist, is that what I called it? Continue. Yeah. Let's try a lower distance. Let's try 250. Ooh. Conflicting types for dist have int. Oh, okay. I called the vector dist as well. Then just call this okay, moment of truth. Dude, I think we did it. We did it. Wait. Never mind. Never mind. We didn't do it. Why does it flicker like that? Dang. I guess we didn't do it. Oh, hold on. This needs to be abs. Right? Wait, hold on. Instead of 3 abs, let's just do the dist square abs to save instructions. The calculation was wrong. Very true. Wait, no. You, oh, dude. Yeah, you do need this. I was just being dumb. I had a moment there. Dude, I think that this is more fun than actually working on my game engine, to be 100% honest. Could have just used disk squared. Yeah. I mean, let's try this then. But then our max dist has to be, what should our max dist be then? Oh. I missed, to have more fun than tutorial series on this PS1 stuff when I understand it. Oh, well, yeah, I shouldn't have done that. Implicit declaration of... Oh, wait, do we not have abs? Up. I may need to include a different header file. Standard lib.h. stdlib.h gives us abs. Now what though? It said that we had overflow because of this being a UN8T instead of a 32. Oh, actually, something really cool that we have here is 16. Whoa. No, the bandwidth channel? I think they rebranded. Yeah, I saw earlier that that was a thing. Okay. This is where the wall is supposed to be. Okay. Yeah, no wall. Yeah, no kidding. What happened to the wall? Yeah, good question. I think we're culling it out, is what's happening. If t is this squared is... Oh, wait, wait. No, I'm right. Oh, we're supposed to increase max dist. What am I doing? What am I saying? This is supposed to be like 5,000. Let's try, well, 10,000. I don't know. I just want to see something on the screen. Wall is cold, yeah. was cold indeed. We gotta increase this rotation speed, like for real, man. We're gonna do it the cheap way though. We'll just do this. Unit issue? I mean, like, how high do we want this max disk to be at this point? Ooh, like, I don't see anything. This bass solo is going on for way too long on this Bill Evans album. It's just like, it's just a very long, let's just see, are we still drawing the wall? We are definitely still drawing the wall. Yes, still drawing the wall. Oh yeah, it has gravity applied. It has gravity applied, 100%. Okay, you know what, let's try the other square root. Square root. What's the other square root that we saw? Don't make me find it. Square root 0. Square root integer. Yeah, let's try this. Square root 0. I'm just making sure that my math is correct. Yeah, my math is correct. Can you log the D? It's I square root, and I don't even think that that's a thing. I think that that was lying to me. I couldn't find it in a global search of the documentation. Bro, there's something in this tree. The tree is going crazy. Okay, let's change the max disk to reasonable now. Let's go to 850. Okay, I mean, this is just... What? Am I stupid? Oh wait, I'm dropping the max dist again. I'm doing the thing again, where I'm dropping the max dist instead of increasing it. Bro, I'm so dumb sometimes. Hold on. I mean, this is like really high. I mean, am I losing my mind here or what? I feel like I'm going crazier. Okay. Okay. So you're telling me that this is it? There just ain't no way that that's a correct value. Try to cull from the cube and not the camera. That's a good idea. I'd have to get the center of the cube though at every frame, which is, I mean, it's just such a large number, right? That's just such a large number. Apparently it's something within like this range that like makes it actually cull. There we go. Wait. Okay, we crashed. This is incredible. Hold on. You know what I'm wondering actually? Are we being stupid? If these are both negative. No, I'm not being stupid. I think that this is an angle of, I think that we've reached the limits of the PS1. Where we should generally, I think that even culling this is already like, this is one wall. This is one wall. This isn't multiple walls, so. So let's try it. Let's try not culling and just doing less. Try not culling, doing less. Gosh, I'm lagging. What the heck? All of a sudden, my music is lagging, my computer is lagging. Oh, my duck station is... Whoa, 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 whoa. 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 Whoa, 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 whoa. Okay. Alright. I was like, why is my computer crying right now? So let's not go out of bounds here. This is gonna be... wait. 60... Wait. What? No. No, this is 8. This is 8. Like, if you wanted to make 4 walls, you would be really limited on what you do. That's kind of what I want to do now, is what if we make, like... Hey, what's up, Lemon Boy? How are you doing? Do I like spiders? I think that they're pretty scary, to be honest. Whoa. Whoa, 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 whoa. Bro, it hacked my computer. What the heck? Wait, what? Why was it rotating? Why were we rotating? Oh. Oh, I know why. Wait, no. I don't really care if spiders are friendly. They kind of scare me, man. They kind of scare me. I think that this was actually interesting because this was one. Was this one less than the count before? I think so. I'm spinning around, which is interesting because we didn't actually touch any of that code. Oh. You're getting tilted from... I'm using i3. I'm using i3. I'm trying to understand what causes us to rotate. Okay, so we no longer crash if we have less polygons. This is a pretty solid frame rate. If you think about it, this is a lot of polygons actually. So if I was to half this, this would be 9 then? 9, 9, 9, 9, 9, 9. Is this a PlayStation game? Well, I'm not really making a game yet, but I am testing the software in the library and learning about it through testing stuff out. Yeah. Huh. We have a rogue triangle. Let's turn off the culling code. We don't need to cull anymore that aggressively. I don't see a wall anymore. Or I see one little bit of a wall. Yeah, I don't really understand why there isn't a wall anymore. There is this like triangle that's kind of sticking out of it, and I think that that's the wall. But for some reason it isn't getting fully drawn. Well, I think I'm gonna go eat dinner here. Oh, let's get rid of... Oh, well no, that wasn't affecting the time. Oh, there it is. There's the wall. There's the wall. I'm kind of interested actually to see if we can make a hallway. I kind of just want to make a hallway. Do I watch Rick and Morty? No. I don't really watch any TV. Last TV I really watched was like Breaking Bad or something. You'd want to set the... this is going to be 0 minus 4. Negative 4, negative 400, negative 450. And you want half of that, so 225 for that. And then it looks like I was almost there. I did my math wrong, I guess. So much white noise, is there? Let me hear. No, I mean, that's my microphone. That's... Yeah, it is cicadas. Maybe that's what he's referring to. For me, it's normal. We have them going all the time here. They're very loud. You can hear them inside. I guess my math was wrong. Zero minus 4 times 100 minus 50. Oh, thanks, Lemon Boy. I didn't always have a relaxing microphone. This stream was pretty jank back in the day. We had a lot of fun. I doubt that this is it. Yeah, now it's... That's the right Y value, though. What music do I like? I like a lot of different music. I don't really know. I like Prefab Sprout. I like Big Star. It's one of my favorite bands. Okay, so, I'm gonna go eat dinner here. I kind of want to keep working on stuff here, actually. I think that I'm having fun, but I guess I'll end the stream for now. Maybe I'll come back, maybe I won't. What am I eating for dinner? I don't know. But yeah, I might come back and work on stuff. Or maybe I won't stream it. I don't really know yet. But yeah, I'm having fun here though. This is a lot of fun to play around with. This is a really nice palette cleanser from working on my own engine. This is a lot of fun, actually. And believe it or not, I thought that this stuff would be impossible for us to figure out, but we're kind of figuring it out slowly, so it's pretty fun. Alright, well, I may or may not see you guys soon, so. Alright, peace out.